We've got a Ryzen 5 3800X. We've also got the Taichi X570. Let's take a look. Alright, check it out. I've got a Ryzen 7 3800X, retail from Micro Center, doing some experiments, going off reservation. Also got the lovely Taichi X570 and also the Taichi X470 over here in a build. This was sort of a follow-up, and we'll talk more about this build in a second. But this video is about the Taichi X570 motherboard and its features, because it's got some cool features, and also the 3800X, because the 3800X is kind of unique. I mean, it's 8 cores, 16 threads, it's a single chiplet, 32 megs of L3 cache, base clock of 3.9 gigahertz. That's a fairly high base clock. And then the boost, of course, is 4.5 gigahertz. But the question is, how is this gonna do? Because if you look at what most of the reviews are so far, I think, fingers crossed, on the internet, it's with the Ryzen 7 3700X, technically a 65 watt TDP part, and the Ryzen 9 3900X. Now, the Ryzen 9 is 12 cores, it's 2 compute chiplets. So if you look at the picture of what's going on, like how AMD's basically putting these together like Lego. So you've got an IO die, and then you've got an 8-core chiplet or 2 8-core chiplets in the case with the 3900X, but 2 cores per chiplet is disabled. The 3950X, that's 16 cores, that's coming. Well, this is 8 cores, and it's on a single chiplet. That's also 105 watt TDP. It's interesting because the chiplets that are mostly out there in the news are the lower power chiplets. Even in the 3900X, the 3900X is a 105 watt processor, but there's 2 chiplets. It's like 2 3600s, 2 Ryzen 5 3600s on one package, basically, if you want to look at it like that, maybe even lower power than that. And so this one's high power. So what does Ryzen do if you let it stretch its legs a little bit? And I think that assuming the heat can be managed, this might tell us a little bit of a story about what we could expect out of the 3900X and the 3950X that's coming if power delivery is no longer a problem and heat dissipation is no longer a problem. Before we get to that, let's talk about the Taichi X570 motherboard. So this particular motherboard was sent by AMD as part of the review package, the processor and a lot of this other accoutrement I've collected over the years or came from Micro Center or whatever, but this particular one is part of the AMD review kit, and I've always been kind of impressed, like, by whatever ASRock puts the name Taichi on. It's kind of a everything you need, nothing you don't kind of a board. I mean, balance. I mean, isn't that kind of the whole name? This Taichi for the X570 strikes me as markedly more high-end than, say, the X470 Taichi. Now, last gen there was the X470 Taichi and the X470 Ultimate. The X470 Ultimate brought onboard 10 gigabit LAN, that sort of thing. This is just the X570 Taichi. At the rear I/O, the layout's pretty much the same as the X470. We've got a BIOS flashback button, a Wi-Fi antenna connection, which, by the way, this is Wi-Fi 6. So it's Intel Wi-Fi 6 at that. So you get Bluetooth 5, and it's, the high-speed Bluetooth and that kind of thing. Also included in the box is a nice antenna. Thank you, ASRock, for finally ditching the rubber duck antennas. This is how you do antennas. This is how the antennas are supposed to be. It's not supposed to be just a little thing sticking out of the back of the computer. This is a good antenna. And look, 3M peel and stick. So you can stick it to the side of your case or the top or behind your monitor, whatever, and locate it where you've got the best wireless signal. We also have 8 USB 3 ports, 2 of which are 10 gigabit, 1 type A and 1 type C. We also have a combo PS2 mouse and keyboard port, which is great for people like me that are still rocking a PS2 Model M. You can have my Model M when you pry it for my cold, dead hands. We also got HDMI out in case we ever get an APU in the future that's got, that's like for something down the road, but an APU that's got like 8 core. I mean, you could use a 3200G. You could use something old in this if you want, but why? Why would you do that? At least with the current generation, you can get a different motherboard. I don't know. We got audio, the audio solution. This is a Realtek ALC 1220 based codec, but the implementation is pretty premium. Gold-plated audio connections, and of course optical SPDIF. There's kind of a unique feature, maybe, or at least ASRock is calling attention to it. The I/O plate is movable. So the I/O plate is built in, but it's a metal just like a piece of sheet metal with a sticker, and it's not permanently affixed. So you've got some play in it to slide it around to line it up exactly perfectly with your case. In terms of power layout and power delivery, we've got a single 8-pin and a single 4-pin. Now, under just about any normal circumstances, you really only need to connect the one 8-pin. So don't freak out if your power supply doesn't have, but one 8-pin CPU power connector. The extra 4-pin does help if you're running a lot of devices that use PCI Express power, because there's otherwise not really any other place. Well, there's a regular motherboard connector, but there's not really any other place to draw the up to 75 watts that can be requested by PCI Express by 16 add-in cards. So if you're going to have 3 graphics cards, or you're going to have a graphics card and 2 of like the old school Fusion IO NVMe drives that you've cranked up to consume up to 75 watts. I mean, these are enterprise grade flash drives that can use 75 watts. You're going to want to connect, and you're going to do overclocking. You're going to want to connect the 8-pin plus the 4-pin. There is an auxiliary 12-volt connection on the regular motherboard power, but that's basically eaten up by the chipset and memory and a few other things. Just depends on how the motherboard's wired and put together. Speaking of which, in terms of like voltage regulation and that kind of thing, ASRock advertises this as 14-phase. There are some doublers involved, but it's a pretty solid layout. It can deliver 600 amps to the CPU. It's a doubled 6-phase from the Intersil ISL 6617A, and the CPU PWM is an Intersil ISL 69147. And so vCore and the SoC are Vishay SiC 634s. They're 50 amp. So you can deliver 600 amps to the CPU. You're not going to hit that. 3800X, 3900X, 3950X, you're not going to be anywhere near 600 amps. Even if like the PBO fairy comes and like sprinkles moon dust on your CPU, 600 amps, not happening. LN2, not happening. So power delivery, phase doublers, but pretty good, not happening. The power, like the heatsink block, there is a heat pipe here. It's 2 big aluminum blocks. It's not finned or anything, but for the 3900X, even in a 4.5 gigahertz overclocked scenario, which I've probably ruined or am ruining the 3900X, dumping that much power into it, it was fine. In terms of PCIe layout on this motherboard, the X570 chipset is great in terms of PCI Express connectivity. It's a PCI Express by 4 connection, 4.0, version 4.0, and 4 lanes from the CPU to the chipset. That's 8 gigabytes per second. The chipset itself also provides PCIe 4.0 connectivity to 2 M.2 slots, also 4 lanes, and then the bottom slot here, which is also PCI Express 4.0. So these 2 slots can run it up to PCI Express by 8. Yes, you can do bifurcation with an add-in card or something like that. The primary M.2 is also PCI Express 4.0 directly into the CPU, and then these 2 run through the chipset, as does the bottom card here. The first PCI Express by 16 slot is suitable for up to a 2.5 or 3 slot card without blocking the next X16 slot, which is nice in terms of a layout. There's also an included Torx bit for removing this giant heatsink. So all of these things in this area that produce heat, ASRock has done something kind of clever. So the chipset, because it is PCI Express 4.0, it can generate a lot of heat. It does need active airflow. And so if you are using a lot of PCI Express 4 peripherals, you will have this chipset fan to contend with. If you don't have a lot of PCI Express 4.0 peripherals, just 1 or 2, this is not going to produce that much heat. You're not going to get that much noise from the chipset fan. A lot of people are worried about that, but it's basically a non-issue in 99 out of 100 scenarios, any kind of like normal scenarios that you're going to have. And if you're really super worried about it, you can add another case fan or 2 just so that you've got more airflow in this area. But for heat, like heat dissipation and heat management, those M.2s, especially the PCI Express 4 ones, can generate a lot of heat. And so this whole thing acts like a heat sink. And in normal load scenarios, the M.2 is going to produce heat when you're doing writes or something that is controller intensive. It's not a continuous load kind of thing. Even if you're playing a game for hours and hours and hours, it's not going to produce a ton of heat on your PCI Express 4 M.2. It's really just those long write cycles. You got a new game and you get the Google gigabit fiber and you're downloading the game at 50 or 100 megabytes per second. And after like 20 minutes of downloading the 40 gigabyte game, yeah, there's going to be a little heat in this area, but this whole thing is all connected together thermally thermally, so it acts kind of like a thermal capacitor. It's going to absorb the heat and sort of even out the heat for the system. You know, yeah, it's dumping some heat onto the chipset, or the chipset's generating heat and the M.2 is generating heat, but this active fan is going to help you cool this whole area even when you're fully populated. Even when you've got a ton of add-in cards in here, it's going to work pretty well. All right, so check it out. Here's our Taichi. This is the intake, this right here. So, and you can see that the expansions card is here. And then we got our MSI Super 2070. This card is nuts. It's huge. It's larger than life, like I am, the way that this is framed up. So you've got the breather here. So you can see as this card runs pretty hot, it's going to blow some hot air into the intake for the chipset. Now, I tested this and it was mostly not a problem except in cases where the airflow was super constrained. So if I had it in a case that didn't have good front air intake, then the chipset temperatures did get a little warm and I could definitely hear the chipset fan. So this is going to be a problem on pretty much all boards though, that have the intake roughly in that area. If this is a problem, you can always get the Aqua, which is a monoblock. Another unique thing that I've got to call attention to that ASRock is doing this generation is Thunderbolt support. Yeah, Intel Thunderbolt. There's a Thunderbolt header. You can get a Thunderbolt add-in card, just slap it in the bottom slot here, connect it to the header. And then you've got an AM4 platform with Thunderbolt support. So I know some of you guys in the audience use my Thunderbolt hack to do some of your pro audio equipment. If you want to make a thread or reach out or whatever, maybe we can figure out some way to actually test your pro audio equipment on this platform. I know on Threadripper hot plug was an issue, but now that we're seeing like the Thunderbolt logo on this, I kind of want to try those same higher end audio equipment, or like the Thunderbolt audio interfaces on this board with the Thunderbolt interface, and see if things like hot plug work correctly, because that's pretty cool. Now I was using Thunderbolt on Linux, and yeah, hot plug was an issue, but I could always manually reset it using Linux. Reset the bus, I mean. Doing that on Windows is a little more challenging. So my heart does go out to you guys that are using Threadripper with Thunderbolt. There are dozens of us, literally dozens of us. But it's exciting to see the platform officially support it. ASRock also has an ITX board that we saw at Computex that has Thunderbolt built right in. That's not available yet, but you can better believe that I'm ready and wait. I've got my contact at ASRock. Like, please send that. I need to test that. I need to test all the pro audio gear. So yeah, Thunderbolt support on an AM4. That's pretty awesome. That might be one reason that you just buy this board no matter what CPU you're going to slap into it. It's like, yeah, Thunderbolt support. Need that. In terms of fan headers, this motherboard has 6 fan headers. One is kind of hiding here by the memory. There's also a USB connection here by the memory, a single USB port, and your RGB connection. So no matter what kind of crazy, USB or RGB or USB plus RGB or USB plus RGB plus 4-pin, or no matter what kind of CPU cooler you've got, your connections are here and here for that. There's also a digital connector here, your 50/50 strip header here at the bottom, as well as a digital interface. There's a lot of options. There's a front panel USB-C connection, as well as a 30-pin front panel USB, and 2 USB 2.0 headers on the bottom edge of the motherboard. There's a lot of little hidden features on this motherboard. It also has a metal backplate on the back of the motherboard, though as far as I can tell, there's no thermal connection to the motherboard. It's really just protection and standoff. I think that I might have liked to have seen a thermal pad interface, especially under the VRM area, because just that much more, thermal mass to absorb heat might help a little bit. Although even, with the stress testing, the 3900X, there really was not a lot of heat production around the VRM. Maybe with the 3950X, time will tell. Now, so how did this fare testing our 3900X and our 3800X and our 3700X? Well, it did great. The BIOSes are evolving, though, and so I will say that they did great at stock speeds. I don't think PBO and PBO plus automatic overclocking are working correctly yet, because the 3900X I have seems to be stable at 4.4 to 4.5 gigahertz. This CPU, the 3800X, is unbelievable. 4475 stable on all cores. Yeah, I don't know. That's at 1.38 volts, Like, is that a lot? I don't know. That might be a little bit much for a sustained all-core voltage. I'm not sure. But yeah, 4475 on all 8 cores for manual overclock. I mean, the max boost on the box is 4.5, and the behavior from UEFIs that I was getting was like 4490 was the highest boost that I was seeing, and usually more like 4475. But 4475 stable on all cores with the manual overclock at 1.38 volts. It seems like PBO is not doing its job, or Precision Boost 2 is not doing its job correctly. And that was part of the reason I picked up a 3800X, is because the things are all over the place. Now, one really interesting thing is that the performance, so there was a version of the UEFI supplied to press for press day that has an older AGESA, like 1.0, 0.2, and there's some other bits in the UEFI that are different. That on the Taichi motherboard at 1080p and 1440p narrowed the gap significantly on the 9900K. And I'm not sure that with the newer UEFIs that has been true. But here's the baffling thing. So that was on the 3800X. The press UEFI with the 3800X was markedly better, but the press UEFI for me for the 3700X was quite a bit worse than newer UEFIs. And I'm not really sure what that's down to. One thing is voltage. So in some other boards that I've tested, like I've also tested the Asus board, the voltages by default out of the box on newer UEFIs are kind of insane. And so if the voltage is insane, you get a lot of extra heat production. The CPU just flat out will not clock as high. There's also, some BIOSes have settings for the voltage preferences, like auto versus normal versus you can undervolt or overvolt or whatever. You got some options for offset. And so auto doesn't mean the same thing as normal, at least in my experimentation. So it's a very, very weird time right now in terms of like Precision Boost 2 and the different implementations from different motherboards. So I think that I'm going to direct you to the level 1 forum. Like if you pick up the X570 Taichi, I'm going to try to collect like the best settings, which is going to evolve over time, obviously. And when you pick up one of these motherboards and you're doing a build and it's like, I want to know what the best settings are. Like I'm not even interested in overclocking. I just want, you know, Precision Boost to do its thing, or Precision Boost 2, or I don't even care about Precision Boost 2. I just want to plug it in and get the absolute maximum performance. Come to the level 1 forums and we'll take a look at it. I mean, all these benchmarks, you know, as I'm rambling and we take a look at the benchmarks here, the 3800X, it's unbelievable. It's unbelievably fast. Yes, the 9900K is faster in single-threaded workloads, but for real-world testing, just like the 3700X and the 3900X, the 3800X tells the story that much better. AMD has done a phenomenal amount of engineering here, and if they have not overtaken Intel, they're certainly nibbling at Intel's heels. And you know, like I say, yes, Intel is faster in some single-thread workloads. And if we look at Shadow of the Tomb Raider and look at the Shadow of the Tomb Raider results, yes, at 1080p, it is at most 18 frames per second faster, usually more like 15. But at 1440p, the gap is narrowed to 1 to 2 frames per second on the 9900K. And if you play over a long period of time, like 45 minutes or an hour, and your computer's doing something in the background, you're going to notice the game do weird stuff a lot more than you would on a price comparable processor like the 9900K. So I think for professional workloads and people that don't want to fiddle with overclocking and people that, you know, 8 cores is enough, I would recommend the 3800X. Like for me, for a Linux box and doing all the cool stuff, which by the way, the Linux thing is fixed on the latest UEFIs. Yay, everything's good. The IOMMU groups are pretty awesome in terms of, you know, all of your PCI Express 4 stuff is broken up on newer UEFIs. Older UEFIs, it's not true, but newer UEFIs, that's all good. But the Linux workstation, that kind of thing for the 3800X, I think it's worth the price premium. If you don't mind fiddling with your machine and trying to squeeze a little bit more performance out of a 3700X, you can get a 3700X close to parity with a 3800X. That story might get better with more updates and improvements to Precision Boost 2. I'm not really sure. Now, in terms of like, do you need an extra cooler? There's a Wraith Prism in the box. I would say that you don't. I would say that you don't really need an extra cooler at all. And in fact, this is a 280 millimeter Asetek, it's NZXT Asetek cooler. It works pretty well. And this is a Scythe Fuma, I think. You know, it's not a Fuma. And so this is the newer one. And I think the Scythe Fuma actually did slightly better than the 280 millimeter cooler. I'm not sure why that is, just very, very slight. But the tower coolers seem to work better than the all-in-one, at least as far as the 3800X is concerned. And it's weird in terms of, you know, heat production, because you get the really small chiplet that's producing all of the heat. And so you have to get that and, you know, dissipate the heat. It might be because the actual like copper finned area inside here, because it's a liquid cooler, is relatively small and centered and not off to one side. Maybe that's the problem. Maybe rotating this a little bit one way or the other would make the difference. I experimented with that a little bit. I'm not really sure. But this, you've got, you know, 6 heat pipes that are touching the base. This seemed to work really well. I don't know. Take it for a grain of salt. This is an initial review. X570, 3800X. I like the 3800X. I like the story that the 3700X and the 3800X and the 3900X tells. AMD's engineering and general awesomeness. Now, I did get to go to a bunch of AMD events and learn more about it, and so I feel like I've been a little bit a part of that process, but very excited by these products. There's competition in the CPU marketplace again, and that will only benefit consumers. And PCI Express 4. PCI Express 4 NVMe SSDs, we got a whole separate video coming on that, so whew. I'm Wendell, this is level 1. If you're thinking about doing a build, I'll see you in the forums.